Namaskar. I am Dr. Vikram Panchal, a professor of chemistry, and I would like to give you some basic idea about chemistry, and that is why we will start this first chapter, Basic Concept of Chemistry. Well, you are already in 11th standard and you have passed 10th standard, so you must be aware of chemistry. It is one of the branch of science, and it is also intertwined with biology, physics and maths. So, let us start what is in chemistry. So, I would like to ask the first question, what is chemistry? Well, nowadays this word is very common. Even non-scientific people also use this word, that they have good chemistry. But here, the chemistry is having some scientific meaning. That is, a chemistry is a science of molecules, varieties of compounds, that is called matter, and transformations. What is transformation of chemicals? That is, one chemical can be transformed to another by means which is known as reaction. Now you know science in 8th standard, 9th standard, even in 10th standard. You have studied science and little bit portion of chemistry. And you know that chemistry means reactions of chemicals. So, it's a very basic concept. And first of all, before learning chemistry, you should know what is reaction. Okay. What is reaction? Well, some of you may refer that reaction means combination of two different chemicals or more than two chemicals, and they form something else. Well, how many chemicals should be there for a reaction? If we take example of reactions, then you can write simple reaction, that is H2 plus Cl2 gives HCl. This you can write, and it is known as reaction. Okay? Well, we have to balance reaction also. And you can see on the left hand side, there are 2 hydrogen and there are 2 chlorines. So we should have 2 hydrogen and 2 chlorine on the right hand side. That is why we can write twice HCl. So this is one kind of chemical reaction. And looking at this reaction, the first thing into the mind is that we should have 2 reactants. They react and give something else that is known as product, and it is called reaction. So in this case, we can say that hydrogen and chlorines are reactants, and HCl is known as product. Okay? And one more example. If we take hydrogen H2 plus N2 nitrogen, then we will get NH3 ammonia. Sometimes we mention physical state also. So hydrogen is in gaseous state, so we write G. Nitrogen is also in gaseous state, we also write G over there, and ammonia is also in a gaseous state, so we write G over there. Now it is necessary to balance chemical equation. So we write 1 nitrogen, only 1 N2, so there must be 2 nitrogen on the right hand side, so we write 2 NH3. And we should balance hydrogen. So you can see there are 6 hydrogen on the right hand side, 3 2s are 6, so 6 hydrogen on the right hand side, so we should write 3H2. And this is called chemical reaction. Now looking again at this reaction, you will say that there are 2 reactants and we get 1 product. Can we have more than 1 reactants? Yes. In some cases, you may find more than 1 reactants and it is known as reaction. Can we have only 1 reactant and which gives products? Is it possible? Yes. Why not? For example, if you take calcium carbonate, CaCO3 solid, gives, on heating, this is the symbol of heating, delta, we will get calcium oxide, which is solid, plus carbon dioxide, it is gas. This is also a reaction. But there is only 1 reactant, no problem. So it's not necessary that any reaction should have 2 reactants or more than 2. Even we can have 1 reactant and it gives us product. My question is, why these are known as reactions? Why do we consider them as reactions? Why not action? Why not action? Now what is action and reaction? So you will definitely, according to physics, you will say that action and reactions are equal and opposite according to Newton's law. Fine. But here we use the word reactions. We are not taking actions. Why? Why in chemistry we use only word reactions? Well, you will say that, you might say that when we mix them, they react and they produce something else. That is why this is called a reaction. But my question is, why they react? Why not they act? What is the reason? Well, there is slight difference between action and reactions. You know that reaction is one kind of reflection of action. And normally human beings act. For example, you are acting. Okay? When you perform, it is called action. And the rest of the world react with respect to your action. For example, suppose you slap someone without any reason. Now, whether you slap or not, it is in your hand, and that is called action. Then what should be the reaction? The fellow who got this slap might react in 2 ways. So reactions are very clear. And the results are also known to us. Okay? You can't slap a huge and like Rambo so that you might be in trouble. Follow? So it is very clear that in action you behave. And with respect to that, you are getting something which is called reaction. Follow? Normally, humans act and animals react. Some people have dogs in house, and when anybody who's from the house comes to the house, definitely that dog will react. वो अपनी पूंछ हिलाएगा, पूरा बॉडी हिलाएगा, आपको प्यार करेगा. That is called one kind of reaction. Okay. But can you react like that when your daddy or parents come to your home? Yes, daddy comes and mama comes and like that. You do this? No. So we don't react. Okay. So this is a basic difference between action and reaction. So here, these are known as reactions. That means there must be action before that. Then what is action? Well, if you take a small box like this, in which you have to fill hydrogen and chlorine, and once you fill them with certain ratio and give energy from outside, or maybe require conditions. So conditions are required temperature, pressure in case of gases, okay, concentration, catalyst in some cases, etc. So you have to fix this condition. And once you fix this condition, you will get some result. Okay? So these all, fixing of all conditions is known as action. Because it is in your hand. If you take H2NCl2, then you will get HCl. But if you take H2N nitrogen, then you will not get HCl. Okay? So, you are acting on these chemicals. And once you act, means you are mixing them, you are giving proper temperature, you are providing pressure or concentration and catalyst, then they will react and they produce what they have to produce. So in reaction, results are known. For example, if you put H2NCl2, you will definitely get HCl in the reaction, in the box. Follow? It is not possible for H2NCl2 to control the reaction. Control is in your hand. And that is why they cannot control the reaction. Okay? The process is being controlled by you because you are acting. But once you mix them, then they will do something related to that action, and that is called product. And you know that if I write H2NCl2, you will definitely write the product HCl. But if I write H2N nitrogen, then you will write NH3. Follow? So products are different, but they are specific. H2NCl2 cannot produce NH3 in any case, because it is not in their hand. Follow? So results are known to you. And that is why this is called reaction. In proper condition, hydrogen will react with nitrogen and produce ammonia. With proper conditions, calcium carbonate on decomposition gives calcium oxide and carbon dioxide. So all these things are very clear and specific. Okay? That is why this is called reaction. So in chemistry, you will deal with reactions every time. And that is why it is necessary to understand what is reaction. Okay? So I'm sure now you got some idea about reactions. That we are acting, we are providing proper conditions to these chemicals, and once you mix them, they will produce something which is called product. And they react, they never act, and that is why it is called reaction. Okay? So this is all about reaction. Now, scientifically, we should know, or we should give the definition of reaction, and that is change in state. It's very simple. Change in state is known as reaction. There are types of reactions. So the first type is physical reaction. In physical reaction, you will find change in physical state. Well, chemistry refer mainly three states: solid, liquid, and gas. So by changing temperature and condition, it is possible to convert solid to liquid, liquid to gas, or vice versa. It's possible all the way. So these changes are known as physical reaction. Now particularly we can take one of this reaction, for example, solid. When solid is converted to liquid, it is physical reaction and it is known as fusion. Okay. For this reaction, should we give energy or we will get energy? Definitely we have to give energy, and so it is endothermic process. And for endothermic process, we write delta heat of fusion which is positive. For endothermic reaction, delta H is always positive. So we write positive. Second reaction, where liquid can be converted to gas. Okay. This reaction is known as vaporization or evaporation. Will it be endothermic or exothermic? It must be endothermic. Because we have to give energy. So when we give energy, energy is absorbed by the system. That is why it is called endothermic process. Okay. So the energy required for this is known as heat of vaporization, and as it is endothermic, delta H must be positive. Okay. Next, solid to gas. And this reaction is known as sublimation. It is called sublimation, and it is again endothermic process. And energy required for this is known as heat of sublimation, and it is positive. Okay. Then gas to liquid. Gas to liquid. Well, it is known as liquefaction. Or sometimes it is referred as liquefaction. And here energy is released, which is called exothermic reaction. And heat of liquefaction, which must be negative. Okay. Then liquid to solid. Liquid to solid is known as condensation or freezing or solidification. And it is also exothermic reaction. so that heat of crystallization or lattice energy, it is also known as lattice energy or lattice enthalpy rather, is negative. So these are some examples of physical reactions. Okay. So solid can be converted to liquid, liquid can be converted to gas, gas can be converted to liquid, liquid can be converted to solid. So this kind of changes are possible in physical state, physical reactions. So these are all nothing but different types of physical reactions. Next, chemical reaction. Chemical reaction, in which you will find change in chemical state. Okay. So there will be change in chemical state. This is called chemical reaction. For example, in the beginning we wrote H2 plus Cl2 gives 2HCl is example of chemical reaction. Okay. So how chemical change takes place? How H2 and Cl2 is converted to HCl? That is very important. So in this condition, we should know that what happened during this reaction. See, there is a bond between hydrogen and hydrogen. Similarly, H2 and nitrogen give NH3. These are all chemical reactions. Here, reactants are converted to products. In chemical reaction, reactants are converted to products. When you take reactants, breaking of chemical bonds takes place. And new bonds are formed, that is known as product. Now, if you want to break bonds, you need energy. For example, if you take hydrogen and chlorine, there is a single bond between two hydrogen, single bond between two chlorine, and single bond between hydrogen and chlorine. Bond energy of hydrogen is about 104 kilocalorie. Bond energy of chlorine is about 59 kilocalorie. So if you want to break hydrogen and chlorine, you have to give 104 plus 59 kilocalorie, so that breaking of bonds takes place. Breaking of bonds means we keep them apart. We give energy, energy is absorbed by H2 and Cl2, and hydrogen move away from hydrogen, chlorine also move away from chlorine. Distance between two hydrogen increases, distance between two chlorine also increases. Okay, so we can understand this with the help of graph, that when energy is absorbed, the energy of H2 and Cl2 increased. With respect to that, distance between H and H, Cl and Cl also increases. So we get this new type of molecule, which is in fact known as activated complex. It is known as activated complex, or it is also called intermediate, or this is the transition state and it is intermediate. Okay, it is known as intermediate, and it is not product, it is only intermediate. In this case, there is no attraction and repulsion between two hydrogen, no attraction repulsion between hydrogen and chlorine. Even there is no repulsion or attraction between chlorine and chlorine. So all atoms are completely free, and they can move here and there. They move in a different directions. By chance, in this movement, if hydrogen collide with chlorine, then there are chances of formation of bond between hydrogen and chlorine, and we will get product HCl. Okay, but when hydrogen and chlorine combine, there is always attraction between H and Cl. Due to this attraction, they come closer and they form a bond. And in this process, energy is always released. Therefore, energy of atoms decreased. And so that when new bonds are formed, which is exothermic, the energy of the system decreased. So when hydrogen attract chlorine, they are coming close to each other. In this case, distance between two atoms decreased. Simultaneously, due to attraction, energy also decreases. And so, when product is formed, energy released, and we may get HCl over here. Now, whether HCl is above H2 or Cl2 or below H2 and Cl2 depends on energy released. I told you that in this case, about 163 kilocalories absorbed, 104 for hydrogen and 59 for chlorine. On the other hand, when one bond between hydrogen and chlorine forms, it releases 103 kilocalorie. So there are two bonds formed between 2H and 2Cl. So about 206 kilocalories released. So here look, we want to reach over here from basic state H2 and Cl2 and 163 kilocalories given. Okay. And 163 kilocalories given. Okay. So when, see, hydrogen and chlorine is having zero energy. Because they are elements, their energy is zero. If you give 104 kilocalorie to hydrogen, the breaking of bond takes place. If you give 59 kilocalorie to chlorine, the bond will break. So total 163 kilocalories given to hydrogen and chlorine, so that breaking of chemical bond takes place. Okay? But on the other hand, when hydrogen and chlorine combine with each other, the energy released is more than energy given. And about 206 kilocalories released. So this reaction is exothermic reaction. It is called exothermic reaction. Once again, we start reaction with hydrogen and chlorine, and energy of hydrogen and chlorine is accepted as zero. And why? Because they are elements. When hydrogen absorb energy, two hydrogens move away from each other. Chlorine also move away from each other, and breaking of bonds takes place. The energy required to break hydrogen is 104 kilocalorie and chlorine is 59 kilocalorie. So total 163 kilocalories absorbed by the system, so that breaking of hydrogen bond and chlorine bond take place. On the other hand, when hydrogen combine with chlorine, we get HCl, and it is exothermic process. Energy released. When one HCl forms, it releases 103 kilocalorie. But here we are getting 2 HCl, so total amount of energy released is 206 kilocalorie. That is why HCl is below H2 and Cl2. So here in this case, energy released is more than energy absorbed. Follow? And that is why this reaction is exothermic reaction. So in exothermic reaction, energy released during bond formation is more than energy given for breaking of bonds. And in endothermic reaction, it is the other way. Energy released during bond formation is always less than energy required for breaking of bonds. So we have two types of chemical reactions, endothermic reactions and exothermic reactions. Okay? Next. What is the importance of studying chemistry? Well, chemistry is used in many areas. In fact, everywhere chemistry is used. For example, we experience many more chemical phenomena from the morning we get up till we go to bed at night. The comforts in the human life have increased because of chemistry. For example, early morning you get up and it's necessary to brush the teeth. Even before you go to sleep, you must brush it. In fact, we should have habit of brushing the teeth after having some food. Okay? So, what is this? It is nothing but chemical. This is chemical. The toothpaste which we are using is also chemical. After brushing the teeth, you must take bath, and for bath we need soap. So soap is also one kind of chemical. You need water to store, so bucket is also chemical. You have to wear clothes, this is nothing but chemical. You have to store something in the vessels, all utensils. See, this is very important. Well, I don't use it, but definitely you all are using comb. And this is nothing but pure chemical. Imagine if the plastic is not being invented, then how will you comb your hair? Of course, there are wooden combs are available, but you can imagine if you use wooden comb, then what would happen to you? So, this is the importance of chemical. Very small things, but it really gives you luxurious life. All these utensils which we are using are nothing but chemicals. Shoes which we are wearing is chemical. See, everywhere you will find chemistry. All vehicles are chemicals because they are made up of metals, alloys and so many chemicals. You can use this because of chemistry. Okay? Well, how will you run this vehicle? Without fuel? It's not possible. So fuel is also chemical. We will have very less amount of fuel left. But anyway, scientists will discover. You are all scientists. You may try in future to discover new kinds of fuel so that we can use it without disturbing environment. Coal is chemical. Biodiesel is used nowadays. It is also chemical. Wood is chemical. You love this. This is food, and food is nothing but chemical. You need protein, vitamins and carbohydrates. These are major three things which we require. We should eat a lot of proteins and vitamins also. So green vegetable is very important and protein is also very important. It's like a wall. See, if your body is like a wall, and if you want to construct your body, you need bricks, and brick is nothing but protein. Well, if you want to align bricks in certain way so that you get pure proper construction, then you need cement. So vitamins are cement. So if you eat proper amount of protein and vitamins, then you can have a very good health. Of course, for energy, you need carbohydrates. So when you consume this, you have to use this in proper way so that you can have a proper health. Common household acids and bases are used. You must be knowing that in every house we used to wash or clean bathrooms and other places with acids and some other chemicals which are used. Okay? So these are all household chemicals. Alloys are used for making machines and all. This is made up of more than one metals. It's a mixture of metal, which we call alloy. Then colors, you love colors, Indians love colors, and color is nothing but chemistry. Okay? These are some household drugs which we use. Cisplatin is very, very important medicine. It is only for cancer patients and the people who are suffering from cancer, where they are getting cisplatin or Taxol. So Taxol and cisplatins are very important drugs nowadays available in the treatment of cancer. Well, you will find some misuse of chemistry also. Okay? For example, this one, explosion, where people are using chemistry, RDX, dynamites. These are explosives and used for spreading terrorism. This is really misuse of chemistry. This is one kind of pollutions which is produced by chemicals. See the effect of pollutions. Plastic. Okay, it is one kind of polluted material. Once we use it and when we throw it, it's very difficult to destroy plastic. And that is why use less plastic. Well, industry is using many chemicals, fuels, and they produce lot of pollutions. Nuclear bomb is also one kind of chemical reaction, nuclear reaction, when fission reaction takes place. But again, where chemicals are used, uranium is used in this case. See the effect of explosion. Greenhouse effect. When, because of combustion of fuel and so many things, carbon dioxide is produced, which behave like a mirror on top of the sky, and that is why the sunlight in night time will be reflected from the earth and should pass through so that earth become cool. But because of the layer of carbon dioxide which act as a mirror, and it will reflect heat again at night towards the earth, and that is why earth atmosphere remain warm even at night. And that you must be feeling that this is in summertime, even at night time it's very hot, and this is called greenhouse effect. CFC is one of the important culprit which eat ozone, and that is why depletion of ozone takes place due to use of CFC. You must be knowing what is CFC. It is chlorofluorocarbon. Well, it is necessary to protect crops, and for that we spray various kinds of insecticides, fungicides and pesticides for this. But they are harmful to us, because when we eat such vegetables and food which may contain some amount of these insecticides or pesticides, and we eat them unknowingly, and it really damages our system. Green chemistry. Well, nowadays it is a new concept, and in this concept is really good, where we have to carry reactions in such a way that we should not disturb environment. So the chemistry involved in production of chemicals without damaging the environment is known as green chemistry. Well, nowadays some other materials are also used, and they are known as new materials, and for that we are using we are using some new kind of material. For example, you know that if you want to conduct electricity, we use wire, and you must be knowing that in wire there is a metal called copper. So copper wires are available which conduct electricity. This is our day-to-day use, you must be knowing this. But scientists have developed a new kind of plastic. Then they can conduct electricity, and they are known as conducting polymers. Well, polymer is nothing but organic compound and it is made up of basic molecule, very small molecule. But when these small molecules combine with the same type of molecule in more numbers, then it becomes polymer. So polymer is a giant macromolecule of organic compound. Okay? And such polymers, if they contain double bond, then they can conduct electricity. For example, the polyconducting polymer is this one, which I am showing you. Here n means infinite, it can be any number, and this is known as polyacetylene. Well, the basic molecule of polyacetylene is HC triple bond CH. This is called acetylene. And from acetylene, if we polymerize it, we will get this molecule, which is called polyacetylene. The second one, there are so many, but I'll give you a few examples of the such. The second one is a linkage of benzene and vinyl group. Which is known as polyphenylene vinylene. It is called polyphenylene vinylene or PPV, and it is also good conductor of electricity. Well, there are so many polymers are nowadays available, which normally polymers are insulators. And you must be knowing, if you pick up any wire, for example, this is wire, okay, this wire is having coating and you can touch it and nothing happens to you. Why? Because it is polymer and it is nothing but one kind of polypropylene or polyethylene, and because of this, as it is insulator, nothing happens to you. But inside this plastic, you will find copper wire. But imagine a plastic which can conduct electricity. So it's so good for us, because then we can save metals. Okay, there will be no problem of corrosion, because copper is having big problem of corrosion. So if we use plastic or conducting polymer, then it's easy for us to use it. Follow? Next is optical fiber. Or they are also known as fiber optics. Well, transparent fiber made of high quality extruded glass or plastic, they are known as optical fibers. So optical fibers means transparent fiber made of high quality extruded glass. And glass is nothing but silica, SiO2, or plastic. Their main function is to the function of fiber optic is it is used as a wave guide to transmit light between the two ends of fibers. That is the main use of fiber optic, function of fiber optics. And fiber optic is used in fiber optic communication. Which permits transmission over longer distance and without any loss. That is very important. Copper wires can be used, but there are a lot of losses of waves and more resistance is there. So in optical fiber, this problem is not possible. Next material is miniaturization of solid state. So miniaturization of solid state, that means we try to compact material for our requirement. For example, deep space mission have a strong need. Deep space mission have a strong need for compact, high power density, reliable and long life electrical power, and long life electrical power generation and storage under extreme temperature condition. That means we can use very high temperature. Even at low temperature, it is possible to generate electricity. And miniaturized thermoelectric generator devices, which we call MTGD, are developed to fulfill this requirement. So this kind of new materials are nowadays available, and that is due to chemistry. Okay.